So 5C, page 314, if you haven't turned there already. I'm just saying. You know, or as I like to say, page pi times 100. Because it is. 5C. First thing, I hope, Nicole, you went like this. Cosecant of x equals 3. We do have to get the trig function by itself. Do I have a triangle with a 3 in it? No. I have a triangle with a root 3 in it. So this is not going to be an exact value. And I also said to you, we're not going to use a graphical approach. We're going to do this algebraically because that was actually faster than the graphical approach. So what did we do then? Well, before we had special triangles, I said to you, how do I solve cosecant? I don't, I would say. We flip both sides. Cosecant goes with what? I'm going to rewrite this as flip this side to make it sine x, flip this side to make it the reciprocal of what was there instead of 3 over 1, 1 over 3. Now I'm going to say, okay, cast rule. Which trig function? Why, it's sine. Positive or negative? Positive. Reference angle. Oh, I can't find the reference angle with an exact value because, Amanda, I don't have a special triangle that matches this. What did we do before we had special triangles? Oh, yes. We used our calculator, and I better make sure my calculator is in radians. And I just realized you probably will need one. I'll get you one a bit later. Inverse sine of 1/3. The reference angle is 0.34, I guess. 0.3398, no matter how I round that off, whether I round it off to there, it's going to be 0.34. So the reference angle is 0.34. So that angle is 0.34, and that angle is 0.34. Right? So my first angle is going to be, my theta 1 is going to be 0.34. My theta 2, how would I calculate that one? Pi minus, and I'm just going to do that on my calculator. Pi minus my last answer, 2.8. So that's the answer to 5C. And then for 6C, they want the general solution for both of these, and I've written these. There's not much room here, unfortunately, but for both of these, we would say plus multiples of 2 pi, because cosecant goes with sine, and sine period is 2 pi, where n is an integer. Same for this one, cotangent of 1/2. I would flip both sides, because I don't have I have a triangle. Oh, I do have a triangle with a 1 and a 2 in it, but I don't think I have a triangle that has a tangent of a 1 and a 2 in it. You can't make it work for any of your special triangles. You'll have to go tangent equals -2 over 1. Okay? Is that all right? And we said, oh yeah, now we are, calculators are fair game. Any others from the homework? Yeah. 9C. Okay. Get the cotangent by itself, yes? So you went cotangent x equals -1 over root 3. Yep. Do I have a triangle with a 1 and a root 3 in it? I can do this as an exact value then. I don't need to go to my calculator. Okay. Cast rule. You know what? It's here and here because cotangent goes with tangent and it's negative, so it's negative there and there. Okay? And I'm so glad you asked this one, by the way, because I get to make a little point. This is the 1, 2, root 3 triangle. Yeah, Roxanne? 1, 2, root 3. Now, remember I said back here, how do I solve cosecant? We flipped it. The reason we stopped doing that was we actually flipped cotangent in the triangle, because we said this. Cotangent goes with what? Tangent. Tangent is what over what in terms of SOHCAHTOA? Opposite over adjacent. Here's where we flipped it. We then said cotangent is adjacent over opposite. We were flipping it, but in our heads. Adjacent over opposite. You know what? It's this angle here. Right? But there's still some more. It is that angle, yeah, adjacent over opposite. Which is, how big is that angle, Roxanne? Good, thank you for bailing yourself out there. I agree, pi by 6, pi by 6. And so here's the two angles that you get. 5 pi by 6 and 11 pi by 6. And for both of those, we're going to add the period, which this time, Roxanne, is tangent, because tangent is the ugly cousin. However, check in the back. That's not what they have. What do they have? In the back? No. Yeah, because you know what? I did this wrong like a complete idiot. It's not pi by 6. Sorry, Roxanne. I did a mistake. It's this angle up here. The reference angle is pi by 3, right? So, I'm sorry. They would have had this. Good gosh, Mr. Dueck. 2 pi by 3 and 5 pi by 3. But that's not what they have either in the back, is it? Sorry, say it louder. This is what I want to make the point. Now that I've hopefully recovered from my stupid mistake, and that was sloppy. Sorry, my bad. Why don't they have this second one? Well, tangent is a little bit weird. It is the ugly cousin. Pi. Or just to make the common denominator easier, Roxanne, I'm going to call that 3 pi by 3, because isn't that still pi? Yes? If you add 2 pi by 3 to 3 pi by 3, you know what you get? What is 2 pi by 3 plus 3 pi by 3? As it turns out, as soon as you write the general solution, it actually already generates the second one there, and it's redundant. I won't take marks off if you put both of them, but what they're saying is, oh, by the way, tangent and cotangent, as it turns out, because any solutions are always the period apart anyhow, they're always pi apart. When you go general solution, the first one generates the second one. You don't need to write the second one anymore if you really don't want to. I usually write them both just to cover my bases. But when you look in the back and you'll say, where'd the second one go? Add the period to the first one. I bet you that gives you the second answer, which is why it's not in the back. Is that okay? Okay. We now enter the big leagues. And I'm going to tell you right now, this question, there's going to be 2 or 3 of these on the written section of your test. It's going to represent about 20% of your test. This topic. Turn to lesson 2. Quadratic trig equations, second degree trig equations. So it says this. In this lesson, we will be solving second degree equations where the power of the trig function is 2. Where you have a squared and itzel, you have also a non-squared. See, when there was just a squared, we got the sine squared by itself, and we could square root. But now if you get the sine squared by itself, you got a sine on the other side, which doesn't help you much at all. How are we going to do this? We're going to factor them. We're not going to use a graphical approach to determine an approximate solution. We're going to use the cast rule and special triangles, or if not special triangles, reference angles. However, it would behoove us to do a quick review of factoring. Is the previous page, move your calculator, is that blank? No. Okay. You can either watch or write this down somewhere in a blank page at the back of the book. I've learned, because you haven't factored much lately, many of you have forgotten it. So here is a quick review of factoring. And I always start out by asking, when I say factor, or when I decide I'm going to factor, what's the first thing that we always, are getting the message, always look for? You're right, Carson. Or Tyson. Yeah, always look for greatest common factor first. Always. Okay? Good habit. Because you may still have something left in the brackets once you pull the GCF out that still factors, but everything will be smaller, which is good. Factor. 3a squared plus 5a. I'm starting out in the shallow end. How does this factor, Amanda? Okay. And what will you have left behind? Good. Factor. 9a squared minus 4b squared. This is the second. First type of factoring was GCF. I'm doing about 3 weeks of Math 10 in about 10 minutes, by the way. GCF? Say no. No. Then we count the terms. Because you guys, in your limited math knowledge, only know one other trick to factor 2 terms. Are there 2 terms here? The only trick that you know to try for 2 terms is you say to yourself, is there a minus sign between them? Is there a minus sign between them? Is the first term a perfect square? Is the second term a perfect square? Then you can use difference of squares. There are other 2-term factoring. There's difference of cubes. There's sum of cubes. You don't know them, so I can't give them to you. How's this factor? 2 brackets. What's it factor into? Y'all remember? What? 3a minus 2b. Square root of the first term, square root of the second term with a minus sign between them. And then square root of the first term, square root of the second term with what between them? A plus. Yeah. By the way, factor. You want the clever trick? X minus root 7. X plus root 7. We told you in Math 10 that that didn't factor. We lied. Technically it does. That's difference of squares. It's not a clean, perfect square difference of squares, but doesn't that still match the same pattern, Kirsten? Yeah. I'm not going to be throwing that at you this year. It comes in handy like once every 3 or 4 years. I've come to a question where I can save myself a lot of time if I recognize it's actually a yucky difference of squares, but I tell you, that'll be a lot easier than trying a whole bunch of other stuff. And the third thing we show you are trinomials. Factor x squared plus 12x plus, oh heck, subtract 3, 32. GCF? Greatest common factor? No. How many terms, Shannon? So it's not difference of squares. Then we said, okay, if it does factor, we glanced in a certain area first, because if there was something missing, it was way easier. We looked right there. We looked at the squared term. Can I call it the quadratic term, please? Because we use math terms. We looked at the quadratic term, and you said, has it got a leading coefficient, or is there just a invisible 1 there? Has it got a leading coefficient, or is it just an invisible 1 there? These were easier. This is where you said, hey, this factors into 2 brackets. I know that. I know the first term is x and x. And then we said 2 numbers that multiply to 32 and add to positive 12. Positive 8, positive 4. And you did a bunch of those, I think, in Math 9? I think. And 10. But here's where you hit the wall in Math 10. It's these next ones. And unfortunately, that's going to be almost all of the questions I give you this year. Questions that look like this. Six x squared plus 13x plus 5. Six x squared plus 13x plus 5. Jessica, GCF? How many terms? 3, so it may be a trinomial if it factors at all. How do we check? Well, first of all, we quickly glance at the leading coefficient. Does this have a leading coefficient? Now, there's various methods. There's the box method, there's the guess and check method, and in fact, I usually use the let my mind go blank and suddenly the answer pops into my head method, and I don't know how to explain that to you. You do a few thousand of these over the years, and suddenly, somehow you build a factoring circuit in your brain. It's what I used to teach when I did this in Math 10. I would give my honors Math 10 kids 100 of these, literally. And by about question 60, all of a sudden I could see most of them start racing. What had happened was their brain had developed a circuit. They were just seeing the answer. I don't know how to explain that or do it. But there is also a method called factoring by grouping, not groping, Andrew, grouping. First, we have to ask if it does factor. And here's the quick test. You ask, look at the first number. Katie, what's that? Look at the last number. You ask, are there numbers that multiply to 30 and add to 13? Where'd the 13 come from? Middle. Are there numbers that multiply to 30 and add to 13? Then it will factor. It doesn't tell you how, but it will. That's the quick way to test whether you need to use the quadratic formula or not. First times last, can you multiply those and add to them? Then you're good. What are two numbers that add to 13 and multiply to 30? What we do is we break this up. So we drop the 6x squared down. We drop the plus 5 down, but we break this 13x up into the 3x and the 10x. And it doesn't matter which order you write it in. I could have written 3x plus 10x, or I could have written 10x plus 3x. Sometimes one will be easier than the other, and that's fine. And then this is why we call this factoring by grouping. It's also called the decomposition method. We're decomposing. In our mind, draw a little line right there. We group them into twos. We GCF the first two. We greatest common factor of the first two. What's the greatest common factor from the first two here? What's left behind in the first two? 3x plus 5. We GCF the second two. What's the greatest common factor of the second two? There is one. It's the obvious one that we always forget. Positive or negative? That reminds me to put a plus sign right there. And if I factor out a 1 itzel, what's left behind is just the original. You'll know you've done it right if what? Both brackets are the same. And then how did you read your final answer? Do you remember? It was the bracket is your first factor. And then the second factor was in front of each bracket. What you're really doing is you are now factoring out this monstrous GCF. There is a 3x plus 5 in both terms. Pull it out, what's left behind? That plus that. Very quickly, Cassandra, in your head, imagine if I'd put the 3x there and the 10x there. The GCF would have been a 2x. Okay? The GCF here would have also been a 2x. And I would have been left with a 2x and a plus 1 in the first bracket, 3x plus 5 left behind. It still would have worked. Order doesn't matter. That's how you factor these. If you do it a different way, Katie, go ahead. I don't care. We're going to do the same thing, but instead of an x or instead of an a, we'll have a trig function. It says this on page 317. Just as with polynomial expressions, trig expressions can be factored as well. The ability to factor trig expressions will be useful both in this unit and another unit. And in factoring trig expressions, we apply the three basic factoring techniques. Common factor, which I always check for first. Difference of squares, which I always check for next because it's pretty obvious. Two terms with a minus sign. And then trinomials. Says factor the following expressions. Ashley, can you read 1a to me, please? And Ashley said very quietly, because that's Ashley, 8 tan a plus 4. I agree with it, but here's what I'm going to write above it, because this is what I want to see in my mind to make my life easier. In my mind, I see 8x plus 4. Except instead of an x, what do I have in my original? A tan. And until you get good at this, Roxanne, you may actually very slightly write a simpler version of the yucky one above it, factor that, and then just replace the x's with whatever. How would this top one factor? Oh, come on, people. Okay, GCF, yeah, 4 bracket. Say it. Okay, don't write this down yet. I'm going to write 4 bracket 2x plus 4, except now I'm going to say, hey, wait. Instead of an x, what did I have in my original? So replace every x in my answer with, yeah. Plus 1, that's what I said. Thank you. Wow, I'm off today. I'm not going to give you one like A. Too easy. B, maybe. It's a quadratic. How does this factor? Well, what's the first thing you check for? GCF. Is there one? Now, I'm going to tell you what this is the same as. By the way, I used X here because they had a letter A here. What letter do they have here? I'll use a capital A. Those are my 2 fallback letters, but I don't want to use the same letter and confuse myself. This is really the same as a squared minus 3a, except instead of an a, what does my trig function have? Sine. Okay, how would you factor the top one? It'll take out. How will we factor the bottom one? Take out the. There's no a. How would I factor the bottom one? Take out the Shannon, sine, right? The GCF. Factor a sine out. What will I have left behind? Well, you had a sine squared. That's a sine times a single sine. A minus, a 3, and nothing. C. Again, I'm going to argue that when I glance at C, Matthias, I really see this. Four a squared minus 1. That's going to give me my strategy. Sorry. I usually close that door. I forgot today. Reggie, GCF? GCF? So, no. Right? How many terms? 2. Oh. Minus sign? Yes or no? Yeah? Perfect square? Perfect square? Difference of squares. So this is going to factor into 2 brackets, right? But it's not going to be 4a squared square root because I don't have an a in my original. What do I have in my original? So what am I going to write here? Two sine x, 2 sine x. I agree. What else? Plus 1, minus 1, or minus 1 plus 1. Okay. Two sine x minus 1, 2 sine x plus 1, or 2 sine x plus 1, 2 sine x minus 1. D. Okay, now I'm going to try not writing that little small term above it. I'm just going to try and visualize. GCF? No. Nathaniel, how many terms? 3. Is there something in front of the quadratic term? Oh, so this one I can use my Math 9 method, which was a little nicer. That was, oh, this dropped down, but it wasn't a squared anymore, right? It was cosecant Cosecant, because if it was an x there, it would have squared, it would have been xx. Yes? Now what? What are two numbers that multiply to negative 28 and add to negative 3? Someone doesn't know his times table. Ah, thank you for recovering for me, Nathaniel. By the way, how can you check if you're right whenever you're factoring? Yeah, FOIL it out. You better get the original question, right? Unfortunately, the ones I'm going to give you the most are E. Are E. Now, for what it's worth, it is possible to go, well, let's see. There's a 2 cos squared. I'm pretty sure they gave me a 2 cos. Don't write this down. And a cos x. And then you kind of let your mind go blank and you go plus 4 minus 1. I have no idea how I do that. I've just done a bunch of these. But I'm pretty sure that's the right answer. Let's prove it. See if my brain blank method works. GCF, Itzel? No. How many terms? 3. 3. Let's try this again. All right. Scene 1, Act 1, Take 2, and... You know what? I can't make fun of you because I'm off this morning as well. So you ready? It's how many terms? 3. Okay. Is there a leading coefficient in front of the quadratic? Okay. If it factors, we're looking for two numbers that multiply to negative 8 and add to 7. Are there numbers that multiply to negative 8 and add to 7? What? So let's go 2 cos squared x plus 8 cos x minus 1 cos x minus 4. GCF out of the first term. 2 cos x. And I'm left with cos x plus 4. GCF out of the second term. Now, here is the only, well, here is one of the tricky parts about factoring by grouping, not groping, Andrew, grouping. There is no GC, well, there is a 1, but there is also one more number, a negative 1. How do I know I want to pull out a negative 1? Because I already glanced at this bracket and I noticed everything is positive, and I'd like everything here to be positive left behind. How can I make everything positive left behind? Pull a negative along with it. So I'm going to factor out a negative 1, and that's going to give me cos x plus 4. So what's my final answer? There's my first bracket, cos x plus 4. And my second bracket is how do I do them in my head? Itzel, what were the two numbers that you mentioned? Numbers that multiply to a negative what? 8 and add to 7. Okay? Can you see the 8 and the negative 1 gives me 7? I'm kind of reverse foiling quickly, and I think this is what I showed you a while ago. This is how I do them, which is, by the way, the best way. But you got to do a few hundred of these to develop that little magic. So that's factoring. Now let's take it one step further and solve quadratics. Says, page 318, solving a second degree trig equation using a graphical approach. No. That was easy. Example 3, solving a second degree equation using an algebraic approach. Yes, this is what I'm going to demand of you. There's going to be 2 or 3 of these on the written and 1 or 2 of these on the multiple choice. Here is the equation. Oh, and they went between 0 and 2 pi, so no general solution. I'll just find the first 2. What kind of an equation is this? It's a quadratic. How do I know, Carson? It's got a square. Before I start factoring a quadratic, what do I have to do first before I do anything else? Make the quadratic equal what? So easiest way to do, now the easiest way would be to minus this to this side, but you may notice I hate this quadratic term being negative. I never teach kids how to factor with a negative there, and the reason is you never need to. Just plus it over to the other side. So even though it technically be less work to move this here, I'm going to move both of these to the left side. I'm going to rewrite this as positive 2 sine squared plus sine x minus 1 equals 0. Okay? How are we going to solve this? We're going to factor. GCF? No. Itzel, how many terms are there? 3. Andrew, is there something in front of the quadratic term? Ugh. So, we're going to look for two numbers that multiply to what? Negative 2, right? First and last. And add to 1. What are two numbers that multiply to negative 2 and add to positive 1? Positive 2 and negative 1? Would that work, my friend? Don't forget the obvious ones, right? Positive 2 and negative 1. Positive 2 and negative 1. Let's drop the sine 2x down. Sorry, the 2 sine squared x. Break the sine x into positive 2 sine x, negative 1 sine x, and then drop the minus 1 down as well. Don't forget. Again, Katie, what we've done is we've decomposed the sine x into that. By the way, you'll notice 2 sine x minus 1 sine x is sine x. It turns back wholly into my original equation. Now we group in our mind. Andrew, GCF? Left behind, sine x plus 1. Right? GCF, I think this one also, what do I want to pull out as a GCF? A negative 1. Okay. I end up with that. Now we're not done. All we have done is factored. The question Ragjit did not say factor. It said solve. Okay, now what? Well, you may remember way back when, from your Math 11 days, when you had a quadratic and you had the factored form like this. Do you remember you could just glance at this and tell me the roots? What were the roots? What were the roots? Nope, no. It was change the sign of this number, divide by the coefficient, change the sign of this number, divide by the coefficient. Remember doing that? Oh, what if you had just nothing there? What's the root of that bracket? Positive 5. Oh, what if you had an x in front? What did that give you as a root? 0. What are the roots? Except it's not x equals 1 over 2. It's going to be x equals sine x equals 1/2. What are the roots? We get two equations when all is said and done, and we're going to solve them both independently now. And I need to give myself a bit more room, so let's be a bit more judicious in my space, Mr. Dueck. This right one here, sorry, this left one here, sine x equals a half. Do I have a triangle with a 1 and a 2 in it? Yeah? Oh, then let's use special triangles. Cast rule. Leah, sign positive or negative in this question, in this factor, in this solution, in this equation? Here and here. The triangle we're talking about, I think, is the 1, 2, root 3 triangle. Which one has a sine of 1/2, the bottom one or the top one? Let's see. Sine is opposite over hypotenuse. Opposite. You know what? That one is a sine of 1/2, yes? How big is that angle? Yes. My reference angle is pi over 6, which means that this angle is pi over 6, and this angle is pi over 6. What's my first x value? What's my second x value? 5 pi by 6, yes? Now let's go to this equation. Shannon, can you read me this equation, please? Ah! Alarm bell's going to go off. Did you say -1? Okay, cast rule is not going to work here. This is going to be one of those. It's on one of my axes. Let's do my little unit circle. You awake now? Sine on the unit circle, and the sine is y over r, but the unit circle was a special circle. We said r was just plain old 1. That's why we were able to use this trick. So sine is just y. What you're really asking is, when am I -1 high? It's your y coordinate. Am I -1 high right there? How about there? How about there? How about there? What? Hey, what angle is that? Amanda. There. There's your roots. 3 solutions for this quadratic. Sometimes you'll get 4, sometimes you'll get 3, sometimes you only get 2. Can't have 5 unless we change the period. Question, Roxanne? You good? Now, that's the answer to A. Roxanne, what does B want? General solution was just to add the period. Which trig function are we dealing with here? Did they put anything in front of the x to change the period at all anywhere in the equation? Anything right there? No. Anything right there? No. You know what the period then is going to be? Okay. So the general solution is going to be, you know what? I'm going to write x1 is pi by 6. Underneath it, I'm going to go x2 is 5 pi by 6. Underneath that, I'm going to go x3 equals 3 pi by 2. I'm going to put a curly arrow for all of those. It's plus 2 pi n, where n is an integer. That's it. That's a quadratic trig. Almost the longest questions you'll do all year, but not quite. But almost. Next page. So it says, in each of the following, use an algebraic procedure to find the solution on the given domain, and then write the general solution. Okay. What kind of an equation is this? It's quadratic. Itzel, you know how I know? It's got a square. Before I start factoring, What do I have to do to every quadratic before I can even start solving it, Nathaniel? Make it equal to. This one already is. Yeah. And you know what? Usually they will be. We'll usually do that step for you. Not always, though. Okay. Ryan, GCF? Give me 1 second here. Ryan, GCF? No. How many terms? 2. Minus sign? Now, look up for a second. I actually snuck these ones in last unit because this is a quadratic. You could also solve this by getting the sign by itself plus the 1 over, divide by 4, and then square root both sides, plus or minus. And I'll show you why you end up with the same thing. But let's factor this like a difference of squares. It's going to factor into 2 sine A minus 1, 2 sine A plus 1 equals 0. What are the roots? And you know what? Well, okay. I could, I think, just say plus or minus 1 over 2. Put your pencils down for a second, look up. See, the other thing that Shannon and I said, I could have plus the 1 over, divide by 4. I could have got this. And then I could have said, how to get rid of a squared? How do I get rid of a squared? Plus or minus, and you'll get the square root of 1, which is what? And the square root of 4, which is, can you see you also get a plus or minus 1 over 2? Either, I usually use this method because it's faster. And I can do it all in my head. But for what it's worth then, it is going to be easier for us to combine these as sine A equals plus or minus 1/2, because it's going to be the same reference angle for both of them, Katie, so why not, reduce our workload? Oh, do I have a triangle with a 1 and a 2 in it? I do. Oh, let's go special triangles, exact values. Cast rule first of all. Tyson, this says sine is positive. Yay. And negative. Yay. 4 answers. The triangle we're talking about is the 1, 2, root 3 triangle. In fact, Leah, I'm pretty sure the reference angle is going to be a half again because we just did a sine with a 1/2 like one question ago. Reference angle is pi by 6. Right? So that angle, that angle, that angle, and that angle are all pi by 6. How big is it? I guess since they're using A, I'll use A. If, Kirsten, on the test you were not paying attention, and instead of A1 you wrote X1 or Theta1, I don't take marks off. I'm fine. I figure out, you switch variables, but I know we're used to using X. But they used A. I'll be consistent. Kirsten, how big is A1? Yes. Can we keep going? Can we? Oh, this is so much fun, Kirsten. Let's try it. How big is A2? That's 6 pi by 6, so 1 less than that. Yeah. Isn't this fun? Let's keep going. How big is A3? That's pi by 6 more than 6 pi by 6, which is absentively. And then A4 would be all the way around, but not quite. That's 6 pi by 6. This is 12 pi by 6. Did you say 11 pi by 6? Because if you did, you're right. Smile and wave, right? That's the answer to the first part of the question, which said solve. What does part 2 say? Find the what solution? General, I've run out of room. Can you clue in that we would just list all 4 plus 2 pi n because we haven't changed the period at all? And it's the sign. Ooh, tangent, ugly cousin. A little bit more nervous here. What kind of an equation is this, Holly? It's quadratic. You know how I know? It's squared. So what's the first thing before I start to factor? What do I do first before I do anything else? Is it? Okay, let's factor it. What's the first thing? Always, 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 always. Is there one? Is there something that... What? What? Oh, you go, girl! Factor the tan out. And Holly, what will I have left behind? Tan x plus 1 equals 0. Make that plus sign look less like a times sign. Okay. What are the roots? This one gives us tan x equals what? Pardon me? Right, you're right. This one gives us tan x equals what? Yeah, it's like we had an x in the front last year. It gives us 0. Shannon, could you read this equation here to me, please? Okay, that's going to be an alarm bell. Could you read this equation to me, please? It's not an alarm bell. Wait a minute, Mr. Dueck. You said when it's zeros and ones and negative one. Okay, I fibbed a bit. Tangent is the ugly cousin. There is actually a special triangle and cast rule that will work for this. Because actually, Shannon, I don't see negative 1. You know what I see? I actually see that, and I say, do I have a triangle with a 1 and another 1 in it? I do. Let's do this one first. Where is tangent 0? Cast rule is not going to help me because 0 is neither positive nor negative. I have to fall back. Unit circle is not even really going to help me. I got to fall all the way back onto, hey, tangent is what over what in terms of x and y and r? Now here's what I don't like. See that x right there, Amanda? See that x right there, Amanda? They have nothing to do with each other whatsoever. I would prefer that they put a theta or an a there, because as soon as I got x's here, they're nothing, not the same. Anyways, what would make a fraction work out to 0? What does make a fraction work out to 0? When the top is 0 or when the bottom is 0 or both? When the top is 0. What this is really saying is, therefore, your y coordinate is 0. So now I can draw my little unit circle. My y coordinate's how high I am. How high am I right there? Holly? Ah, what angle is that? If I'd gone all the way around, but if I'm just starting out, what angle is that? Yeah, say it with authority like you know what you're talking about. Okay, one of my roots for this side is x1 is 0 right there. And I think I'm also 0 high right there. Yes, Holly? What angle is that? Oh, is it less than 2 pi or equal to 2 pi? I hate that. Scribble that out because I don't want to get 5 roots for a quadratic. That just gives me the creeps. But 2 pi for their question would be an answer. I would give it to you this way without the or equal to. Here, not an alarm bell. This is the cast rule. Trevor, which trig function did they give me? Positive or negative? Here and here. Oh, do I have a triangle with a 1 and another 1 in it? Yep. This is the famous 1, 1, root 2 triangle, where this angle here, actually both angles have a tangent of 1. This one's a little harder to mess up. But you do have to remember what the angle is. And this was the most common mistake I saw on the test, because I did give you a question that had this angle. I saw a bunch of kids do this. Oh, well, that's, it's not. What is that angle? pi by 4. And sadly, then that would domino all the way through all of their answers. And ugh. So this is pi by 4. This is pi by 4. Mr. Dueck, that means that my third answer is 3 pi by 4, right? Because it's 4 pi by 4, one less. My fourth answer is 7 pi by 4. And you may notice, Amanda, since they did ask for the general solution, but I told you I can't fit it in, but if they did ask, if I add pi to that, I get that one. They probably in the back of the book wouldn't bother writing this one again for the general solution. Oh, and you may notice that here's the first one. Where's the next answer? Pi. Where was the next answer, even though we didn't include it? 2 pi. Where would the next answer be? 3 pi. They might even combine those, even though the period is 2 pi, just by a fluke, the fact that these happen to be pi apart, they might just say, hey, your answers are every pi, because they are. That's just a coincidence, but it's certainly a shorter way to write it. So keep your eyes open in the back of the book when you're doing answers. I'm going to temporarily pause. We're going to do the next two a bit later. I want to get you started today. So the first bit of the homework is 1 all. I got to give you, unfortunately, lots of practice on this. Uh, 2b and c. I'm skipping the use the graphical approach. I don't know why they emphasize it so much. I think that's silly. (3b and c). Ah, Mr. Dueck, it's got sines and cosines. Make it equal to 0. Factor out a GCF. I think it ends up being nice. Four. You guys got 20 minutes. That's a fair chunk right there. I'll assign more tomorrow.